Hey everybody, this is Larry. This is February 26th. Hit the like button, hit the subscribe button, join me on Discord. A couple of days left, and let me know what you think about this really long month for me, even though it's only 28 days. Okay, so today's problem is validate stack sequences. Okay, so yeah, distinct values aren't true if this could be the result of push and pop on an initially empty stack. What does that mean? Or like, what is... Yeah, so I usually stop these lives, so it's a little bit slow, just fast forward or something like that. I'm just trying to understand what this is asking more than anything. Okay, so say you pushed, you popped. Push 1, 2, 3, 4, 5, 4, pop 4, 5, and then pop 3, 5. Whoops. Oh, you pop to get to 5, you pop to get to 3, pop to get to 2, pop to get to 1. Okay. Is it some sort of greedy? I mean, it's going to be some sort of greedy, but I'm trying to think about how to think about it. And maybe some sort of stack as well, right? It's either that or this like one invalid configuration, and we have to figure out how to calculate that invalid configuration. Okay, so what does it mean? Well, when one is pushed, well, one could be popped as well, right? So if we have something like, 1, 2, 3, 4, 5, pop could be 1, 2, 3, 4, 5. We just push one, pop one, push one, pop one, right? So what does this mean when one is here, right? Well, one is here means that, is this some sort of almost like almost divide and conquer or something like that? Because okay, if one is here, then what does it do to the popped, right? That means that everything after this has to be either before or after, right? Is that true? 2, 3, 4, 5, right? I think so. Because, going from push to push, the contradiction is that, I'm guessing, I'm just still trying to figure out how to prove this. I'm guessing that if like there's a 2 that comes after the push, that means that has to be, when one gets popped, it has to happen either afterwards or before, right? And all of them has to be consistent. So you basically, that means that given a push, it has to be either the beginning or the end. Is that true? I'm still trying to think whether that is true, even though I think, to be honest, if this was a contest, I would just YOLO it. But I think, I mean, it sounds reasonable, but reasonable doesn't always mean, like I get greedy algorithms wrong all the time. So okay, but yeah, I think so. Let's give it a try. I mean, I maybe this will be a proof by AC type problem. So yeah, so we're gonna convert popped into a deck so we could remove from the. Now I guess we'll just keep track of. I mean, I've been having a tendency to convert everything to a deck instead of yeah, let's do it. Because so my warning is that if you want to do this cleaner, you just have a pointer on the popped and then another pointer on the left. Okay, fine, let's do it that way. I just wanted to keep it really simple. But left is equal to 0, right is equal to length of popped minus 1, and then for x in pushed, if x is equal to pop of left, we increment left. If else, if x is equal to pop of right, right -1, and we assume that you got length, otherwise then this would be wrong. But yeah, else return false, return true. And of course this is because they have distinct values as well, because otherwise you could have, you know, 1 in the beginning and the end, and then you have to make a decision, and right now there are no decisions. It is some sort of greedy as a result. Because there only could be one place where it's happening. Okay, so this looks good. That doesn't have any confidence because it's a true false, but let's give it a go. Ooh, wrong answer. Okay, so at least I know that that's not true, or like my answer's not right. Okay, let's take a look in here then, because I didn't really spend that much time disproving this either. But okay, so this is a pop, and this answer is, oh, so you can get here. So okay, so my assumption was wrong. So you push the 2 on the stack, push the 1 on the stack, pop the 1, pop the 2, and then get the 0. Okay. So I was wrong on this one then. I think it's a combination of, but I don't know how to do it. Like here, I only looked at one direction, but you can just do a while loop for, you know, the front equals the front, the back equals the back, or maybe those two. Okay. I mean, again, you can do this with pointers, but for easy purposes, I'm just going to convert this to a deck. And then just again YOLO this while length of pushed is greater than 0, and of course they both should have the same length. So oops. I don't know that this is true. I mean, I know that this would solve this one, but I feel like that is part of the invariant, and that's why I'm doing it this way. But I think my invariant was a little bit incomplete the first time for sure. But I'm just like half to it. Okay, so let's go. Okay, and if this is still wrong, they have to really think about what's going on. Okay, wow, huh. And to be honest, I didn't really spend that much time on this problem, thinking about counter cases. Usually, for a contest, I might, but at least after the first one. But today I'm just really tired, and it's been a rough day. But okay, so here, what's the answer? Oh, I'll put true, but the answer is false, because 2 cannot be the last. Okay, so I'm wrong again. Wow. Okay, because I assume that we can get rid of the 2 and then 1 and the 0 is easy, right? But in theory, you have to do the 1 and then the 0, and then the 2 to get the 2, and then the 0 and the 1. Okay, I think there's, now I kind of see the invariant a little bit, which is that I have to figure out the invariant. I think that's the biggest part about this problem, and the biggest problem, or the tricky part about this problem, is that there's some, I know that there's some ordering with respect to here that has to be true, where okay, is this one of those problems where you can only sort by swapping the front or something like that? see. What are the answers for this? I forget. For these inputs, I mean. Did I put this in there? Yeah, okay. Did I just remove the code? Yeah, okay. Because now you can swap these two, but then here there's no way to output to swap them. Wow. I am actually stumped by this one a little bit today. Maybe I'm just a little bit off my game. Oh, I think I'm just being too clever, too smart. I think we can just simulate it in a greedy way. And if you've been watching up to this far, I apologize. This is a long video for that. But I think you just keep on pushing stuff on a stack. You see a 4, you pop. You see a 5, no popping, so you keep on pushing. And then just simulate it that way. I don't know. Maybe today is just not my day. Or this week has not been my week. But okay. So again, for lazy reasons, I'm going to convert them into decks. So we can just pop instead of using variables, but of course this will add to the complexity, which we'll talk about in a bit. So yeah. So while pop length of pop is greater than 0, so we want to make sure that for every character that we pop, yeah. Oh, actually, I guess this doesn't have to be. It's fine though. Okay. Actually, I guess this doesn't have to. It's fine because this could be a for loop. Fine, let me do it that way then. For x in popped, we want to get from push while we can, right? While push of 0 is not x, we append it. We append pushed of 0. And then push dot pop left, right? So then we keep on going until this is true. Okay, and also length of push is greater than 0. Now let's say that they are equal to 0. Then, well, we can push dot pop left, or if length is pushed is greater is equal to 0, we return false. Otherwise, we just pop left and we don't have to push it to the stack. Yeah. Well, now we have to look at the stack first. Right? I am messing it up today. Okay, so look at you go 1, 2, 3, 4, or 4. Yeah, you keep on pushing until it is in the stack. Otherwise, I think this is roughly what. And then the next number is, yeah, if x is equal to stack of -1, the end of the stack, and the length of stack is greater than 0, stack dot pop. And we continue because then we just go on. Okay. Otherwise, if we're able to go for every number, then we are done. Is this right? Okay, I mean at least it's correct for these. So let's give it a submit. Cool. Yeah. So I don't know. I think I was just a little bit. I don't know. And again, for this, you can just use the pointer to keep it in O of 1, and if you however, it's still going to be O of n space because we have a stack right here. Can you use an implicit stack? Not usually, because then you have to point to the I mean, so you if you're able to modify the input, you can do it in place, I guess, with no extra or one extra space. But otherwise, since that's not, you could implement the stack on top of pushed, the variable. But since we're not going to ignore that, this is going to be O of n space because we have a stack, and O of n time because, well, we just go through the array, and for each number in popped, we either push or pop each number in pushed once. So that means that for each number here, we're going to use the stack once, and for each number in pop, we're just only going through it once, right? So even though, and they both are length n, so it's going to be O of n length. Even though it looks like an n square looped, you have to amortize the time, average it out, so that you know that each item here gets looked at once, each item here gets looked at once. So as a result, it's n plus n, which is O of n. Cool. I'm gonna cut it short today, or as short as I can, because I don't know, not feeling well. So hope y'all do okay, and I will see y'all tomorrow. Bye bye.